Hi everyone. Today we will discuss about the structure of the Mosfet. So before talking about Mosfet, let's talk about amplifier. So let's make amplifier. So this is input, input supply. This is V in, a sinusoidal signal. Okay, and let's take its amplitude is 1, and there is a voltage controlled current source. So it is let K V in. So for taking output voltage, I'm using one resistance R out. Okay, so for calculating this R out, see this current is going like this. Okay, so now apply the KVL on this side. The value of current is K dot V in, so it will be V naught, and so it is plus minus, then it will be plus. Okay, R naught dot the current flowing through it, which is K dot V in, okay, equal to 0. So V naught will be equal to minus K dot R naught dot V in. Now you can see in this equation that V in is the amplified version of this, this much. Okay, you can see that. So now let's but there you can see it's degrees, so it will be like okay, it will be like this, somewhat like this, and the amplitude will become equal to k dot r naught times 1. Okay, similarly here, this will be minus k dot r naught dot 1. Okay, so this will be the amplified version of this input. So we can create this amplifier with the help of the MOSFET also. Okay, so how we can do that? We will see. So first of all, we have to, how can we make that amplifier? So uh, we want one current which is controlled by voltage. I mean, we want a voltage controlled current. Okay, so how we can do that? Let's make an uh, one device. We can take one capacitor. Okay, so I'm taking one thick pen, blue one I can take. So what is a capacitor? Capacitor keep two metal, okay, and in between it remains insulator or dielectric. Okay, so I'm making one capacitor. This is a metal, okay, and in between this there is a dielectric, and I'm keeping here one p-type semiconductor. Okay, so what is that? It is metal, okay, and this is a dielectric. Dielectric, okay, it is SiO2, and this one is p-type semiconductor. I'm keeping this name here, p-type semiconductor. Okay, now I am applying one input voltage here. Okay, there it is. Let's call it is VG. Okay, and so because of this VG, what will happen? Their positive charge will come. You know the capacitance. Okay, the body positive charge will come. That positive charge will attract electrons. Okay, so the electrons will come near to the dielectric surface, right? Okay, so now if so see, we want one current. So for that current, that charge, and this charge should flow. Okay. So for this, we have to apply one voltage. Okay, like this. That the name of this voltage is V1. So because of this V1, then electron will start flowing in this direction, like this, like this. So the current will start flowing in opposite direction, right? So now we can say that the current is flowing through it. Okay, this is, let it is ID. Yeah. So now we are increasing Vg. We increased Vg. So what will happen? If we increased Vg, you know that Q is equal to Cv. If I'm applying voltage across capacitance, then I'm increasing this voltage, which applied to the uh, capacitor. This charge will increase, right? So see, Q will increase. You can see that, see, this is increasing, so charge will increase here, so charge will increase here also. Okay. Since this charge, let give name A and B to these two terminal. Okay. Since charge increased, so we can say resistance between A and will reduce. Okay. So it states that current ID will increase. Okay. So you can see that we are increasing this Vg and this current is also increasing. Current is also increasing. If we are decreasing it, then current will also reduce. So you can say that this current is depending on this Vg. So we can say that ID is voltage controlled current. Okay. So it can work as a amplifier, right? So this is our observation one. This is current is depending on this Vg. Okay. Now second observation. What is second observation? That is, if I am reducing this step, this, okay. So what will happen? The thickness of this dielectric. So if I will decrease the thickness of this, then also the charge will increase here. Okay. Since charge increased, then again current will increase. So the second is, if the thickness, I'm calling it T. Okay. If thickness of dielectric, which is T, okay, reduces, it means the charge will increase. That means ID will increase. Okay, these 2 points. What is the third observation? If I increase V1, okay, then ID will increase. So these are the three observations from this structure. Okay, since see, this is M. We can take metal M from here, and this is S, and from this is, sorry, O from this, and this is S, semiconductor S. So it is MOS. So it is a MOS structure. Okay. Metal oxide semiconductor. Yeah. Okay. This M stand for metal oxide semiconductor. So it is a metal oxide semiconductor. That's why it's MOSFET. Okay. MOS stands for metal oxide, metal oxide semiconductor. Okay. So now, yeah, one more thing. So we saw on top this structure was like this. there was metal, then this, and the connection was like this. Okay, so in fabrication, the die looks like this. Okay, so we can't make these connection from sides as we made here. Okay, we can make connection from these contacts from top only. Okay, so this is not a valid one. So what we can do, we can make this connection on top. But how? Let's see. So for this, we have to take semiconductor, that is P-type semiconductor first, and P-type semiconductor. Then there is oxide. Okay, then one metal. Metal layer is there. Okay, so we want to shift the side connection on the top. So for that, we can do connection here. Okay. Okay, for a better connection, let me remove this and let's write inside it. Okay, so better connection, we have to dope it heavily with n-type impurity. Okay, so these two contacts we can use for giving that voltage by which the current can start flowing. Okay, and this metal, where is my pen? Oh yeah, there. So this is VG. Okay, this is the VG, the input voltage. Okay, according because of which that current was varying. This current ID was um, depending on this voltage. Okay, there is one more terminal. This is called body terminal. Okay, so that body terminal also we can't connect on that lower side. We have to connect in on top. So for this we can connect here. So we have to dope it heavily with P type purity, and this is P body. Okay, so this terminal is called source and this terminal is called drain. I'm writing full name source and drain, and this one is called gate. Okay, so let's make a 3D figure of this. And this is called Mosfet. Okay, this is a Mosfet structure. Mosfet structure. So from this figure we can see a Mosfet have four terminals. Four terminals, which are gate, source, drain, and body. Okay, yeah. So let's go to the next page and let's use which color I should use. Blue color. Okay, so for this first we have to take substrate. Okay, I have taken substrate that is P-type substrate. Okay. Hmm. Now we have to make it an oxide layer. Okay, so for 3D we have to make like this. Okay, and this is going like this. This is okay. Yeah, like this. Okay, let me make it a bit big from this side so we can add body also, right? Mm, okay, yeah. So now for source connection, and this is for drain. this one for body. So this is B, and this is, what is this, source, and this one is for drain. Okay, and this one is for gate. Yeah, this is the 3D diagram, 3D diagram of MOSFET. Okay, so what we have learned in this lecture. So the first thing we learned that the summary we can write it. Okay, the summary or the what we have learned, that is MOSFET can work like amplifier. Okay, can work like amplifier. Okay, and we saw that ID increases when VGS increases. Okay, third point was if the thickness of dielectric is reducing, thickness we can represent by T. Okay, thickness of dielectric reduces, then ID increases. And what else we can? Yeah, we saw the uh, 3D diagram of MOSFET, right? And what? So this was all about today lecture. So in next lecture we will see the derivation of ID, derivation of ID. Okay, and we will see ID versus VGS, and we can see ID versus VDS. Okay, these we can see. Yeah, so that we will see in next lecture. Thank you very much. So let's meet in on the next lecture in the second part of the MOSFET. Okay, yeah, thank you.